Hello! In this video, we are going to prove the following theorem. If a sequence of real numbers has a limit, then the limit is unique. So, just to be clear, by the way, all this notation means is we have a sequence x1, x2, x3, and so on and so forth. Now, what we want to do here is we want to prove that if our sequence has a limit, then that limit is the only limit of this sequence. So, how do we prove that? Well, we're going to suppose that our sequence has two limits, say x prime and x prime prime. And to prove uniqueness, all we have to do is prove x prime is equal to x prime prime. Okay, now first of all, what does it mean for x prime and x prime prime to be limits of xn? Well, if you recall, for x prime to be a limit of xn, what that means is, for every epsilon greater than 0, there exists a positive integer k, such that for all n greater than or equal to k, the absolute value of xn minus x prime is less than epsilon. And similarly, what does it mean for x prime prime to be a limit of xn? It means exactly the same thing as this, it's just instead we have x prime prime there. Now, to prove that x prime is equal to x prime prime, we're going to use another theorem that we have before. If you recall, it was this theorem. Suppose a is a real number. If for every epsilon greater than 0, 0 is less than or equal to a is less than epsilon, then a is equal to 0. What we're going to do is we're going to apply this theorem to prove that the absolute value of x prime minus x prime prime is equal to 0. If we can show that this is true, well, then it will immediately follow that x prime is equal to x prime prime. Okay, so to prove this, what we need to do is we need to prove that this statement is true. Because if this statement is true for absolute value of x prime minus x prime prime, it will follow that absolute value of x prime minus x prime prime is equal to 0. So let's prove this statement. Right, we're trying to prove a statement about every epsilon greater than 0. So give me an arbitrary epsilon greater than 0. Now because epsilon is greater than 0, it follows that epsilon over 2 is greater than 0. Now, since x prime and x prime prime are both limits of xn, it follows that this first statement is true for both x prime and x prime prime. If we consider this statement in the case of x prime, well, since this statement works for every positive real number, it must work for epsilon over 2. So, since epsilon 2 is greater than 0, it follows that there is some positive integer k1 such that for all n greater than or equal to k1, the absolute value of xn minus x prime is less than epsilon over 2. And similarly, there exists a positive integer k2, such that for all n greater than or equal to k2, the absolute value of xn minus x prime prime is less than epsilon over 2. Now, I think it's pretty obvious that there exists an integer that is both greater than or equal to k1 and greater than or equal to k2. I'm just going to call that integer n. Now, we're going to show that 0 is less than or equal to absolute value of x prime minus x prime prime, which is less than epsilon. Now, we already know that 0 is less than or equal to absolute value of x prime minus x prime prime. That just follows from properties of absolute value. Now, since the n that we're referring to here is a positive integer, surely xn is a term of this sequence. So what we can do is we can take this inequality, we can add and subtract xn. And now what we're going to do is we're going to apply the triangle inequality. If you recall, the absolute value of this thing is less than or equal to the absolute value of this thing plus the absolute value of this thing. Of course, we can swap the order of x prime and xn. That's still equivalent. But remember, since n is both greater than or equal to k1 and greater than or equal to k2, it follows that both this is true and this is true. So this expression is less than epsilon over 2, and this expression is less than epsilon over 2. So it follows that this plus this is less than epsilon over 2 plus epsilon over 2, which is equal to epsilon. So through this chain, we see that 0 is less than or equal to absolute value of x prime minus x prime prime, which is less than epsilon. And that's exactly what we wanted to prove. So we have proven precisely this statement. So by this theorem, it follows that absolute value of x prime minus x prime prime is equal to 0. But remember, when the absolute value of a number is equal to 0, that's equivalent to saying that the number itself is equal to 0. So x prime minus x prime prime is equal to 0. But then, of course, it follows that x prime is equal to x prime prime. And that's it, right? We gave ourselves two numbers which happen to be limits of xn. And then we prove that those numbers have to be equal. And that proves that if our sequence has a limit, then it's the only limit. So this completes the proof. And so yeah, that's pretty much the idea of how you could prove this theorem. And yeah, that's pretty much it for this video.